Previously, my group mate Xia Weizhe has talked about the background and introduction part. Also, following the basic idea mentioned above, he explained the first method of taking a picture for black hole in details. That is, we can use waves with shorter wavelengths. However, as he discussed before, it's not a practical way. Thus, let's see the second method of taking a picture for the black hole. It is the method scientists are now using, and it does accomplish a lot. Before we introduce the second way, let's talk about the theory part first. Recall the resolvability which we have learned in topic 4. By applying the Rayleigh's criterion, two distant point objects cannot be resolved if their diffraction pattern overlaps. The equation is given in terms of this. To get a smaller theta, one method is to increase the size of the objective length. Therefore, here comes the second method to take a picture of the black hole. But you may ask, how on earth can we increase the size of the objective length? The answer is easy here. We can simply build an array of telescopes around the Earth. Then its objective length will have a diameter of whole Earth size. Actually, that's what scientists have done in past decade. The project is called Event Horizon Telescope. Here is a brief introduction. EHT is based on 8 telescopes around the world. Those worldwide telescopes form an extremely large telescope. It did works. In 2019, EHT successfully took the first picture of the black hole in human history. You may be puzzled with how it works. The basic principles are as follows. The first step is observing. To simplify the question, we only consider the situation where there are only 2 telescopes. They can observe the electromagnetic waves emitted by the black hole simultaneously. Then, the second step is to collect the data. Because of the difference of path distance, the wave fronts we received are slightly different. See the pictures here. Don't you feel familiar? Yes, the underlying principle is similar to the single-slit diffraction. There exists the phase difference between the 2 electromagnetic waves, but we only use them to calculate the average intensity here. In addition, this is the most important but also the most difficult phase. The next step is analyzing the data. The common method applying here is Fourier transformation. It's optional. You can switch to other mathematical models in analysis. After getting all the signal of a black hole, the picture comes into being. No method is perfect. There are some disadvantages we can improve in the future. The first one is that EHT takes a lot of money. It is reported that it costs several $100 billion in total, only to get one picture of the black hole. And the second disadvantage is that by different mathematical analysis, we can obtain different image. You can see the picture above. Hence, we should explore and select a more accurate model in the future. That's all for our presentation. Thanks for your listening.